All right, everybody, this is the big anticipated episode on Project Rei. I've been super excited to show you guys some of this. I've been working behind the scenes, designing some of the suspension bracketry, and then working with my good friends, Scott and Nick Angell. You'll meet them here in just a second, but we're gonna cover all the suspension geometry. I think we'll be able to build all the rear suspension stuff, get it tacked in place. I think the going to require a little more. We'll see if we can get through all that in this episode. I'm super pumped to show you all the RideTech suspension components and some of our custom bracketry that's going to make Project Rei handle like a dream. When I met Nick, he was in college getting his mechanical engineering degree. He's out of school now, but while he was in school, he was working with the Formula SAE team, and that's where a lot of his suspension design and geometry education came from, was not only engineering, but applying it through the Formula SAE team. They've got a black 67 to 72 C10 that they race in the Optimus series. Well, used to race in the Optimus series whenever I race it as well. Now they're rebuilding that truck, both here to help me plot some of the suspension geometry. So what we have here, and then I did some of the work off camera, setting the frame up at a simulated ride height. So in the previous episode, I talked about the possibility of having to raise the notch in the frame, and luckily I don't. Once I got all the math done, I think we got plenty of compression travel in the notch. Today, what we're gonna do is show you a little bit about the angle of the lower bars. We're gonna run a 3-link, so why we're gonna do 3-link. We're gonna talk about so we're going to place the Panhard bar. We're going to talk about motion as well, on where we're putting the coilovers and how that affects the ability for the shock to control the vehicle's movement. So what we're going to use on this truck is a 3-link rear suspension as opposed to a more common 4-link, and specifically ours is a decoupled 3-link. So the upper 3rd link can compress and stretch on acceleration and deceleration. That just provides more traction, more bite on the tire. I'm gonna let Nick define some of these things for us. There's really 3 things that are important for you to know in designing a rear suspension, or even just looking at a rear suspension that you could buy from another company. 3 things are the rear instant center, the anti-squat percentage, and the roll center of the rear suspension. All of these can be dug in depth. We could spend days theorizing some of these things and really showing you how to calculate some of that, but I don't think we'll get that deep. We're gonna kinda give you a general idea of what's good and what to look for and how to get there. Right now you can see that we've got the lower bars on, and it is at ride height. So you can see that we've got a decent amount of compression left on the stroke of the suspension. And the rear link bar, you guys have probably seen these or heard just that they should be flat to the ground, which is pretty true. So if you ever see a truck that's got a lower bar aimed way up or way down, we're gonna tell you what that does when it's angled. I'm gonna let you talk real quick about rear steer and why we wanna keep this flat.
Yeah, absolutely. So with the lower links flat and level to the ground, that's what we would call as 0 rear steer. And that means the angle of the bars isn't contributing to the rear axle under cornering for the steering. If you have your forward link angled up at the chassis side, so we're running like that, that would put us into what we would call rear steer. And as the truck turns and as the weight transfers from side to side, that's actually going to help rotate the rear axle a little bit. And help you turn in. And the other way that if you're lower in the front, it's actually going to have an opposite effect.
Yeah, counter steer.
Counter steering.
Yep.
So that's what we want to avoid.
I'd set this up to where the front of the bar is a 1/4 inch higher than the back of the bar at ride height. All the geometry of the rear suspension. So that's why it is really important to mock all this stuff up, or even do your drawings with all your ride height measurements. So you'll need to know your tire diameter, and you'll need to know exactly what frame height that you're going to set the frame to. So that's why that's what's been so important about me getting this set up on jacks in the rear end up at these heights, so we can take all these measurements. So yeah, at a 1/4 inch up, we'll have very little rear steer. As like he said, so if we turn left and it compresses, it'll turn the axle just a little bit. If you ever see one of these that is really aggressive, what would be sketchy is like if you're on the interstate doing 70 miles an hour and you turn and the truck leans a little bit, it'll want to dart and it'll feel sketchy, like you didn't have control of that. So that's why it's important to get that flat-ish. Rear instant center. That's probably the thing that's maybe most important. Yep. Going to be defined by the intersect point of the upper and lower bars. And I'll kind of let you get into that if you want to.
Yeah, so up here we've got a little bit of a drawing of our rear axle and our front axle. And then we've got our lower links, and in this case our upper link, but this would also work with a forelink if you had two.
Yep.
And what we're doing is we're drawing an imaginary line between those two, and those meet at a point called our instance center. Kind of what that contributes to is not only our rear steer, but then it also kind of moves us into our anti-squat percentage. Anti-squat, if we want to just talk about what it does.
The traction would be anti-squat, but this is essentially a triangle on instance center, where the tip of that triangle points is where the instance center is. The more aggressive you make that triangle, the shorter the instance center will be, and the more that you spread the front bars apart, it'll create a longer instance center. So if you guys have ever seen like a generic forelink that's on the side of a truck and both bars are completely parallel to itself, then its instance center is infinite. There's no point at which the bars will ever intersect, so it will have like really bad traction. It'll just do burnouts for days because there's not an intersect point. The length of the instance center also contributes to how fast the suspension reacts at traction. So if you had a really short instance center and you just had lower horsepower and you just did like short, small autocrosses, that would actually work pretty good because you could get around a corner and just hit it and the traction would be really fast. On a lot of horsepower, it'll just be too violent. Our instance center is kind of like not long per se, but you want to have it to where it's a little bit slower. A longer instance center is also better for higher power vehicles too. So that's really the main things to talk about is the length affects the speed of the traction, and then that it's important to get that lower bar flat or just inclined slightly up. And then anti-squat. Anti-squat is probably the most important of the percentage for traction. So if you had a vehicle that you're trying to take off on the autocross and it just spins and spins and spins, the anti-squat percentage will also be derived from the instance center calculation. So you want to explain how we get anti-squat percentage?
Yes.
You're really good at explaining that.
So we've already drawn our instance center. And then what we're going to do is we're going to take a imaginary line from our rear tire contact patch through our instance center, and we can extend that as far as we want. And that's this blue line right here. Moving on from there, we have our center of gravity. That's this blue X right here. And so that you can get from your front to rear weight distribution. And then the height of your center of gravity is kind of something we were talking about earlier today.
So it would be a percentage of the height from instance center. Yeah. So if ground to if ground to center of gravity is 100%, your percentages down from there would be the anti-squat percentage.
So we've talked about here, imagine our center of gravity was 20 inches off the ground, and then this blue line connected 10 inches off the ground. That would put us at 50% anti-squat. And again, if that line connected directly to that X, that'd be 100%.
Yep. And so there's lots of theory, well, not theory, there's lots of stuff that goes into calculating center of gravity. It's way too deep for me to get into in this truck. It's really way too deep for 99% of people to get. There's a lot of talk on the internet about picking a generic center of gravity, and that's a lot of times what we do. And you'll even hear people say sometimes that they pick where the camshaft is in the back of the engine off the ground. So that distance and height at where the back of the cam is in the motor is generally where I pinpoint that too. That's what I select. And also, just from my experiences, I like anti-squat percentages anywhere from 80 to 140%. Power, tire compound, weight of the vehicle, a lot of stuff plays a role in what works well and what doesn't work well. I've even seen people design rear suspensions that they say that their vehicle worked really good at 50%, where I've had vehicles that I've had are in the 45% and it has absolutely no traction. I've actually gone all the way up to 140% to get it to where it felt aggressive. So this is just kind of that area to play around in my opinion, would be from 80 to 140% anti-squat. Mm-hmm. And then the last thing, I guess, is talking about roll center. And then roll center, is also really, really important. And this is something that I learned very quickly when I first built my yellow and white truck. The first autocross that I went to, I went on a corner and tried to accelerate, and the inside tire would just spin out. So I spent time thinking that I had a bad limited slip differential, and I've heard a lot of newcomers to autocross say that they need to get a better diff because their inside tire is is not biting, and that's really not the differential's fault most of the time. Most of the time it's the height of the roll center, and that's viewed the back of the vehicle. So Nick drew a really cool illustration here where the Panhard bar intersects the center line of the vehicle. That's the height that you're going to play with. And what we've seen in the past is that, you know, somewhere around anywhere from 3 to 6 inches off the ground is pretty aggressive and works really, really well. Variables play into what roll center works well for you, weight, the instant center of the front suspension, a lot of that stuff plays into this. But look at a bolt-on 4-link kit and it has the Panhard bar centered in the rear axle. That might work. And if your inside tire is jacking up and not getting traction, the easiest thing to do is move the Panhard bar down and it'll keep that tire planted on the ground. So that point also is a lever. So everything pivots on that axis. So roll center is simply the pivot axis. It's the height of the center of the axle. Its height is the center, calculated center of the axle. So everything above that center, the entire truck rolling, can roll there. So if this was above the axle, there's almost no weight that can roll, right? So everything below the truck can swing from that point. So that's why that tire wants to jack. Yeah, so if you see a 4-link kit and somebody has the Panhard bar way above the axle, which I've seen, that is going to be terrible for weight jacking. You may never experience it driving straight down the road, but if you ever wanted to come out of a corner and get in the throttle hard, it will lift the tire on the inside way off the ground. So ours, we're going to get to where we want to in roll center by this, some of these Panhard bar brackets that I've helped design. This is the one that mounts on the chassis side. So I made this little 1/8 inch hole here. This is where the center line of my rear axle is at ride height. So then I know how many inches down from that my roll center is set to. So that's why I've got so many positions in this. And then the one that goes to the axle is dropped down as well. So here's center line of the axle. So I've got a couple heights at which I can put the Panhard bar. That's roll center. Actually, that's everything. That's roll center, that's instant center, and anti-squat. Excuse me, anti-squat. Now we've got the hard part. The hard part's going to be putting the upper link on the truck. It being a 3-link, you know, it's out in the middle of the frame. So we're going to have to build some type of cross member that holds front of the upper link bar. And we're going to have a lot of adjustment in it. So we're going to offset that too. You want to talk about why people offset it, or the theory behind it?
Yes, so we're going to offset the 3rd link, the top link, offset to the passenger side of the truck. We're going to go about 6 inches, but we're going to have some adjustability in that. So the reason for that is as you accelerate and as the rear end torques up, the truck actually wants to twist. And so by offsetting that upper link, we're able to kind of resist that and help keep the truck straight and level as we accelerate. Yeah. That wouldn't be really a big deal if you had a 4-link, because then you've got links on both sides counteracting that.
Yep, so what we're going to do is make plates to where we can put spacers and shim that bar left to right. So we'll be able to go from 6 inches off back down to like 3 or 4 inches off. So I've got the center of our lower part of the shock marked up, and then I'm using the laser to transfer that up to the frame so that we can place our shock mount in the right location. That way the shock will be going pretty much straight up and down from the side. Mark it. I'm not going to be able to drill it by hand. Where I set the inside of the box, like right here.
That was just the center transferred up.
Oh, okay.
So however you want to
I think that's I have the other one.
Yeah, I think that would have worked out well.
So what he's doing, guys, is welding on the upper shock bracket. So we bought those RideTech triple coilovers, and like the specs you get with coilovers, it'll tell you the compress and extend measurement. Well, RideTech goes ahead and gives you your ideal ride height measurement, and it's 14.5 inches. So luckily, with the bracket that we have that we bought from Ridetech. It's got the stud for the lower mount of the coilover, and then I made this one and had these laser, and I TIG welded them together. And it just, without having to get this thing crazy high, it's dead on 14.5 inches. So we're gonna tack these on and then put the coilovers in.
On this one,
Okay.
So that should be our center.
I gotta go that way quite a bit. So that's dead center in that one.
Yeah.
Let's grind more. Can't just say a bunch of sexual jokes in here. All right, we're putting the Panhard bar in, guys. You ready, Dylan? So that's pretty good. The height difference at center. See it?
Oh yeah. I think you're good. That's a lot.
And I can go.
And with that.
Yeah.
Oh yeah. Got one.
It'll look like this needs to roll this way.
It does.
Yeah.
It does need to roll. It does.
What it is just grind inside here just a hair and roll it back.
Oh, okay.
Where?
In here, we need clearance in here. Just clearance.
And so then I just bought a new case. When we were in Hawaii, they only had their bomb pop flavored lemonade for the summertime.
Yeah.
They now released it, so I bought
Okay.
this and I bought the shirt.
Dude's got a full Arizona TT shirt. Panhard bar, we talked a little bit about the roll center height, and it's pretty good. I'm really happy about that. So keep in mind what I said is that the roll center, its height is at the center of the rear end. So we can go up one here, or we can go down a bunch here. And so I'll just show you real quick. And come around here. You can see when I drop to the bottom, it changes in the middle pretty good. So, sorry. So when I go up all the way and down all the way in the middle, you can see there is pretty good height difference. So I'm pretty happy with that. So anyways, Panhard's on and tacked in place. All that worked out good. And then Nick and I just sat down and we made the 2 brackets in software and then a backing plate for them that'll locate the third link on top of the rear end. So what we were doing is kind of going by like the rule of trying to offset the upper link 10% to that side. So we took our track width, which is center of the tire and center of the tire. That was what, 63 and
63.
something. So we did 10% of that. So roughly 6 inches off center is where we put that. And then we made the brackets far enough apart so we can swap spacers around and actually kick the link left to right to play with some of the offsets. Now that we know exactly in space how high that's gonna go, we're gonna start designing the brackets for the front. And the only way to know how to design those brackets is around the geometry. We're gonna go look over Nick's shoulder, see what the geometry looks like. So that upper link bracket that's gonna go on the rear end, and you can see what's gonna get off the side of the third member area. Shoot, there we go. So it's a pretty simple bracket made out of 10 gauge. And then, like I said, now that we know this height, now he can go in here and put that height in his software. And then we can kind of play with the height, really. That's the only thing left to know, right?
Yeah.
Is the height of the front of that third link.
Yeah, so what the software allows us to do is we can input all of the pickup points of the control arms, both on the front and the rear. And then if we look at a side view, we can see we've got our upper link here just simulated at that angle. And then on the right, I'm able to see all kinds of parameters that we want. In this case, we're going for the anti-squat on the rear. So I can play with the height of this, play with the length of that, and then we can kind of look at what numbers we're going for and at that point we can start designing brackets.
Okay, so have you got all my accurate height for the lower bar in it now?
So far, yes. The lowers are in. Same with the wheelbase, track width, all that kind of stuff.
Okay.
So now I'm just messing with this top link here.
Okay.
Currently I've got it at 28 inches long.
Okay.
And then I'm just messing with the height of the front, since we already kind of set the rear with that bracket.
Yep. And so like sometimes it might go like this where, you know, we've fixed those 3 points and then moving this up and down, we can't get our geometry in the spot that we want. So we would maybe be forced to change this upper in the back if we had to.
Yeah.
So for instance, like where you get, will it show you right now where you're getting with the anti-squat number or anything?
Yeah, so I'm able to read the anti-squat. I can't extend the lines, kind of like we were drawing earlier, but currently we're sitting at about 65% anti-squat.
Okay.
But what we can do is we can go ahead and lower this one down, that point down a little bit, and increase that.
So just for curiosity's sake, let's drop it by a 1 inch increment and see what percentage increase it is.
Okay. So in this case, we're gonna go over here to the rear. We're gonna drop that 12 inches off the ground. I'm gonna go back. And about 76, so we gain almost 10% of anti-squat just with that 1 inch drop.
Okay.
So,
but what's its height off the ground right now?
Oh,
like, is it pretty aggressive?
It's currently 12 inches off the ground.
Okay.
So it'd be about 6 or 7 inches higher than those lowers.
Yeah, well, I can take my measure.
Yeah, go ahead.
So what did you say it was?
It's 12 inches off ground at right height.
And then 8 and 3/8 is our difference of jack stand. So what is that? 14 and 3/8? 14 and
20 and 3/8.
it's 20 and 3/8.
Okay, so that's right here.
Yeah, that's at this height. Okay, that's not scary. I mean, we were worried that it was going to be down here or something.
Yeah.
Okay, good. That's not bad. So I guess now we'll try to get a bracket, you know, or some amount for up here.
Yeah.
We'll get a good amount of adjustment up here.
Yep.
All right, it is Saturday morning. We're back in the shop. What we did yesterday, you guys got to see us go through some of the rear suspension geometry, and we got the Panhard bar done and up on the frame and rear end. Today we just finished designing all the third link mounting solutions for both the chassis side and the rear end side. And we're lucky enough to have a good friend in town, Jimmy, that has a laser cutter. So we're able to email him all of our files about 11 o'clock, 10:30 this morning. We went and ate some Mexican food, had a margarita, and by the time we were done eating lunch, he said, come get all these parts. We ran out to his shop, picked up all those laser cut parts, and Nick and Dylan are inside the shop prepping all those parts to be TIG-tacked together. So I'm gonna step inside. It was a little noisy, but I'm gonna step inside and show you where they're at with this. It's really cool. The front chassis side of the upper third link mounting solution is kind of integrated into the Tinworks inner stiffener. And honestly, I really love that. That inner stiffener is so heavy duty. Any of the energy that upper link is pulling or pushing on is all in the inner stiffener and not just a single cross member. So I think it's a pretty brilliant design. Like I said, we're gonna step in here and check out what they're doing. I think that what we're gonna be able to do today is completely mock up the rear suspension, finish it, and kind of give you guys a peek at what it's gonna look like when it's completely done. For the front end, I hate to say this, but we are not going to show the front end or any of what our plan is to do the suspension in the front. There's some roll center issues and some geometry issues that we know we were going to run into, but we've got a very exciting fix for the front end. And you're just gonna have to stick it out with me and wait till the next video. There's gonna be a lot of work that has to be done in software between this video and the next time you see it. Anyways, just hang out. It's gonna be awesome. But for now, let's just look at the rear end. Look at that rear end, boy. How do you feel about the design?
I think it's pretty good.
Yeah?
We're gonna get all tacked up and see how it fits.
That's cool. Okay, well here it is. What was it, 11 o'clock when we sent the files to Jimmy? It's 5 o'clock now, and it went from CAD to a tacked together part in 5-6 hours. Pretty pumped about this. Our theory here is that you would probably want to run the Tenworks inner stiffener if you're gonna be having this kind of rear grip. Our part would replace their rear section here that crosses over, and it'll have the upper third link adjustable mount on it. This is pretty heavy duty. I'm sure this will get refined, you know, as we keep moving forward with this idea, but pretty proud of this. Nick, thank you for designing this and helping weld it together. Dylan too.
I did 2 tacks.
So anyways, we're gonna throw this in. We got one more bracket to weld on the rear end, and you guys are gonna be able to see the full 3-link done. Rear end to see if it's centered. If anything, the rear end is kicked that way just a hair, which is good. All right, well, this is the last piece of the puzzle. Nick's gonna help me square this up and get it offset the right amount. What we wanna be able to do is, like I said earlier, get the bar center to 6 point something inches off center line, so we're almost there. All right, that's gonna do it for the first suspension episode on Rei. We had all intentions of being able to get through all the suspension, calculate all the geometry, build all these parts, but you know what? We had fun working on the rear suspension, and we did a little bit of planning, a little bit of execution on the front, but you're just gonna have to wait and see what we got in store for the front. As for the rear, it's all mocked up and we're super pumped. Like I said, I hope you guys took something away from this. Quite a bit of information in here. As always, thank you guys for watching, and thank all these people for coming and helping on this truck. So anyways, we'll catch you on the next one.